So today we're going to go over the semester 2 review. I'm going to go ahead and do the we do side, and then later on you're going to be doing the I do side to practice for this review. So if you look at this review, you will notice that it's broken down in teaks. So just like the final exam, this one gives you an example of every teak that's going to be on the exam. So for example, on number 1, go ahead and zoom in. So this one is talking about the properties of exponents. So remember that when we are multiplying the exponents, we add the powers. When we're dividing exponents, we subtract the powers. If we have a power to a power, we multiply the exponents. And if we have a negative exponent, we always want to move it either to the top or to the bottom, depending on where it is. So let's look at this first one right here. We have 10q to the 5th, w to the 7th, and 2w to the 3rd. Right away, we can simplify right here the coefficients. So we know that 10 divided by 2 is 5. So I have 5 on the top. And then I have q to the 5th. Since there's no other q's in that first part, I'm just going to go ahead and copy that down, q to the 5th. And then I have w to the 7th and w to the 3rd. So what we're going to do is we're going to subtract that. So 7 minus 3 is 4. And since w to the 7th is on the top, that means the top gets those 4 w's. So right now we don't have anything on the bottom, so we're just going to label this 1. Times, now let's do the same to the other side and try to simplify it. So the only thing it looks like we can simplify at first is the power to a power. And remember, power to a power we multiply. So I have 4q to the 12th over w to the negative 5. Remember that w to the negative 5 needs to come to the top in order to get rid of the negative sign. So we're going to move this to the top. Once it moves to the top, we are now multiplying. So this is equal to 5q to the 5th, w to the 4th, times 4q to the 12th, w to the 5th. So now we can just multiply our coefficients. So we have 5 times 4, which is 20. We're going to add the coefficients of the q's and the w's since we're multiplying. So we have q to the 17 and w to the 9th. That is our answer. Okay, let's look at number 2. Teak 11a says simplify expressions involving square roots. So let me go ahead and scroll there, zoom in. So remember, when we're simplifying square roots, we need to use the tree method. So if I'm using the tree method, I have to remember my prime numbers. So remember, prime numbers would be numbers such as 2, 3, 5, 7, and 11. There's much more numbers after that, but we're only going to deal with the first 5, 2, 3, 5, 7, and 11. So what we need to do is we need to create the prime factorization tree from 512. So we have 512, which can be broken into 2 times, let me check my calculator, 256. 256 can also be divided by 2, which gives me 128, which again can be divided by 2, which is 64, divided by 2 again, 32, divided by 2 again, we get 2 and 16, 2 and 8, 2 and 4, and 2 and 2. Notice that I did not stop until I ended in this prime number right here. Okay, so our next step is to circle all our pairs. So I have a pair of 2's here, pair of 2's here, another one here, and another one here. So what I'm going to do is I'm going to multiply 1, 2 from every pair that I circled together. So I have 2 times 2 times 2 times 2. And then whatever's left, that's what's going to go inside the radical sign. So the only one I have left is this 2 right there. So that's going to go inside the radical sign. So now I just need to simplify. What is 2 times 2 times 2 times 2? So that's 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this simplifies to 16 square roots of 2. And that is the answer. Okay, number 3 says factor trinomials in the form ax squared plus bx plus c. So in this problem, we're going to factor 2x squared plus 7x minus 15. We're going to do that using the ABC method. So remember, when I label my A, B, and C, these are just the coefficients that are in front of our terms. So A is 2, B is 7, and C is negative 15. I'm then going to multiply A times C using the swing method. So A times C gives us negative 30. And then I need to find terms that multiply to negative 30 but add to 7. So multiply to negative 30 but add to 7. And those two numbers are going to be 10 and negative 3. Because when I add 10 plus negative 3, I get positive 7. And 10 times negative 3, I get negative 30. So then to write my pairs, I have x plus 10 and x minus 3. But don't forget to divide by that a term. So we need to divide both by 2. 10 divided by 2 is 5, so this reduces to x plus 5. And negative 3 cannot be divided by 2, so we move the 2 into the front. This becomes 2x minus 3. So that means our factorization of this problem was this, and this is our answer. Okay, number 4 says add and subtract polynomials. So here we're just combining like terms. So all the x squareds need to go together, all the x's, and then finally all of the numbers need to go together. So here I have 3x squared minus negative 2x squared. So I'm going to write it down. 3x squared minus negative 2x squared. Remember, minus a negative turns into a positive, so this is just 5x squared. Okay, now let's combine my x's. I have negative 5x minus 6x, which is equal to a negative 11x. And then lastly, I have my numbers. So I have 7 minus 3, which gives us 4. So if I put this all together, I have 5x squared minus 11x plus 4. And that is my answer. We just combined like terms. Okay, TEK 10b says multiply polynomials. Remember, in order to multiply a polynomial that looks like this, we need to know that that little 2 tells us to write our parentheses 2 times. So I have 6x plus 3 times 6x plus 3. So this now looks like the FOIL method. Remember, FOIL stands for first, outside, inside, and last. So our first two terms would be 6x times 6x, which is 36x squared. Then our outside terms would be 6x times 3, which is 18x. Our inside terms, which is 3 times 6x, 18x. And our last terms, 3 times 3, which is 9. And then the only other thing we have left to do is combine our like terms. And our like terms are these two middle ones, 18x plus 18x, which gives us 36x. So I have 36x squared plus 36x plus 9. That is my answer. Just combine like terms. Okay. Number 6 says rewrite polynomial expressions using the distributive property. So when we distribute, we have to take everything outside of the parentheses and multiply it to everything inside the parentheses. So I'm going to take this 10x and I'm going to multiply it everything inside the parentheses. So 10x times 2x squared gives me 20x to the third power. And then 10x plus 4x gives me 40x squared, and 10x times negative 5 gives me negative 50x. That is my answer. Okay, number 13 says rewrite a binomial as a difference of two squares. So remember, when we are looking at something like this, difference of two squares, we know that 1 needs to be minus and 1 needs to be plus. So in order to find our other numbers, we just need to take the square root of the number in the front of x squared and the number after our minus sign. So right here, the square root of 9 and the square root of 64. The square root of 9 we know is 3, so this becomes 3x on both of them. And the square root of 64 is 8, so this becomes 8 on both of them. That is our answer, this whole thing right here. So if we were to FOIL this out and work backwards, we would get 9x squared minus 64. Okay, number 14 says determine the domain and range of the quadratic function. Domain and range of the quadratic function. So here, we just need to remember on number 14 how to find the range. And you could do this one of two ways. You could graph this on our calculator. Graphing this on our calculator, we know it's going to look something like oops, did it backwards. Graphing this on our calculator, we know it will look something like this, because we know that negative 5 is our y-intercept. So once you graph it on your calculator, all you need to find is that vertex point. And we notice that our y value on that vertex point is negative 5. So since our graph is above that negative 5, we know the range is going to be y is greater than or equal to negative 5. Okay, number 15 says, what is the domain and range of this function? Notice right here, this is an open circle, and this one's a closed circle. Remember, closed circle means less than or equal to, open circle means less than, always. So when we're finding the domain, we need to look at the x values. So the x value right here on this side is negative 7, and the x value over here is 2. So our domain is going to be negative 7 less than or equal to x less than 2 because of those closed dots in the open dot. Our range, we're going to pay attention to the y values. So if I look at the vertex point, my y value down here is at negative 8. And notice this goes all the way up to 0. So I'm going to write 0, or I'm going to write negative 8 is less than or equal to y, which is less than or equal to 0. Number 16 says graph quadratic functions and identify key features. It says looking at the graph below, what is the axis of symmetry? We're going to find that first, axis of symmetry. Remember, the axis of symmetry is the x value of the vertex. So our vertex looks like it's this point right here. So the x value would be 2. So our axis of symmetry is x equals 2. Our vertex, we pointed it out right here at the top, is 2, looks like 9. So our vertex is 2, 9. Our x-intercept, looks like we have two x-intercepts, one right here and one right here. Our x-intercepts are at -4, 0 and 8, 0. And lastly, we need our y-intercept, and our y-intercept is at 0, 8, right here, 0, 8.